Hello nerds, this is Daniel for Rock the JVM, and in this video I'm going to talk about structuring code in Scala with ZIO and ZLayers. Now, this video will assume that you are a comfortable Scala programmer, and some familiarity with the ZIO Basics is preferred but not necessarily assumed. I'm going to take care to establish the necessary foundations before we dive into the problem of this video. Now, as always, this video is most effective if you write with me, and whenever you need to refresh your memory about these concepts or about these patterns that I'm going to show you, just refer back to this video or to the written form at the blog with the link in the description. So without further ado, let's get to our code. So the first thing that you will need if you write ZIO is to add the library definition in your build.sbt file. So right now I have dev.zio %%zio%, and the version at the moment of this recording is 104-2. I'm going to give you the necessary code that you can add to your build.sbt in the blog version. All right, now let's get to the actual code that we are going to write. So I've defined here an object that we are going to use to test some stuff that we're going to write. And this video is shot in Scala 2, but the exact same concepts are applicable in Scala 3 as well. ZIO will also be available in Scala 3. All right, so let me give some background. So the ZIO library is centered around the ZIO type, and the ZIO instances are called effects, which describe anything that a program normally does: printing or computing or opening connections or sockets or reading and writing files and so on and so forth. However, it's worth pointing out that much like other IO monads, constructing instances of ZIO does not actually produce effects at that moment. Instead, ZIO instances are data structures describing effects. All right, so the ZIO type describes an effect which is caused by an input and can produce either an error or a desired value. And so a ZIO instance has three type arguments: an input type, which is called R, which is known as the environment, an error type E, and a value type, a desired value produced by that effect, A. So this is the result of a computation, this is the error produced by that computation, and R is the input of that computation. So ZIO of -R plus E and plus A, with the appropriate variance annotations, are the type parameters appropriate to ZIO. Now, this instance, or an instance of ZIO, is conceptually equivalent to a function from the input or the environment type R to either an error or a desired value. So let me give some examples. I'm going to define a value called meaning of life. This is what I always like to start with. And you can build an instance of ZIO producing a pure value by doing ZIO, which you can import, .succeed with the value, let's say 42. So this is an effect, this is a computation producing the pure value 42. If you want to produce a failure, let's say a failure is ZIO.fail, and you can pass that error as an argument. You can say something went wrong. All right. Cool. So this is how you can produce either a success or a failure with no necessary environment. So if you do ZIO.succeed, there is no need for an environment. The type R is any in this case. Now, real effects, like printing something to the console, are also described by ZIO, and I'm going to import ZIO.console. And ZIO.console provides you some functions that will provide ZIO instances for descriptions of effects that will actually happen if you trigger them. Let me give an example. So I'm going to define a value called greeting as a for comprehension, because these ZIO instances are monadic types and you can have map and flat map methods on them, and so you can chain them with for comprehensions. And I'm going to have something which is the result value of put string line. So this is the print line of ZIO console, and I can print, let's say, hi, what's your name? All right, so this is an effect that doesn't produce any meaningful value. The A value here, the A type, is unit. And let's say I want to obtain a string from the console line. So I'm going to say name, which is the value of the effect of get string line. And again, the unit in the put string line. Let's say hello $name, welcome to Rock the JVM. And these effects, put string line, get string line, and put string line, are chained with flat map, and then finally yield, I'm going to yield some value that I obtained after combining all these effects. Now, I don't really care about the returned value out of this computation, so I'm simply yielding unit. So this whole computation here is a ZIO instance whose result value is unit. So if you hover over this greeting value here, you have ZIO with the input type console, the error type IO exception, and the value type, the desired value type unit. All right, cool. Now, this is a ZIO instance which describes all these actions that are going to be performed to the console, but they're not actually going to be performed unless I actually run it in a main method. Now, if I run a main method and these values are evaluated, these strings are not actually printed to the console because, as I mentioned earlier, ZIO instances are just descriptions of effects, and so my program doesn't actually do anything. And so if you want to actually run these effects, you will have to do the following. You will have to do the object that you want to run as an application to extend ZIO.app. And because you want to extend ZIO.app, you have to define a method called run, which is an equivalent of the main method that takes the command line argument as a list of string. Now, the return value of run here is not unit, but is a ZIO exit code. And we can trigger a ZIO exit code by actually running this effect by doing greeting.exit code. So if you do something like this, when you call the exit code method, the effects are actually going to be performed and the value of that computation will be returned as the return value of this run method. So now, if I run this application, I'm going to have the string printed, hi, what's your name? I'm going to say Daniel, and then after the name is being fetched from the console, hello Daniel, welcome to Rock the JVM is actually performed later. So I hope you get the idea. These ZIO instances are combined much like options or other kinds of monadic values. Now, in a real application, we often need to create heavyweight data structures which are important for various operations. Now, the list of those purposes is longer than we'd like to admit, but some critical operations usually include interacting with a database or a storage layer, either doing business logic, serving a front-facing API, for example, through HTTP, and communicating with other services, and a long list of other purposes that we normally need. Now, if we think about it, most of these heavy data structures are created through some sort of effect. For example, creating a connection pool for interacting with a database, or reading from some configuration file for interacting with business logic, or opening some network ports for your front-facing API, and so on and so forth. So we can therefore conveniently think of these services as a particular kind of effect because this interacts with the real world. And ZIO, this kind of structuring, matches this pattern very well because a service may have dependencies, also known as an input or an environment. A service may fail with an error, and a service once created may serve as dependency or input to other services. So the value will be that service itself. Now, this style of thinking about a service is the core idea behind what is called a ZLayer. And for the rest of this video, I'll write a skeleton for an email newsletter service that will automatically give a user a welcome email once subscribed. Now, the implementations I'm going to give are all console-based, but they can be very easily replaced by a real database or a real email service. Now, the goal of this example that I'm going to show you in this video is to show you how you can plug together independent components of your applications and see how easily they can interact. So let's assume that we're working with user instances of the form of a case class. So I'm going to define a very simple case class. Let's call this user with a name and an email as a string. All right, so this is a very simple data structure. Now, we want to define a service which, given a user, will send them a particular message to their email address. So a simple API would look something like this. I'm going to define an object, let's call this user emailer, and I'm going to define a trait called service, which is inside of this object here. This is hidden here, and I'm going to define a single method called notify. And this notify will take a user as a user and the message as a string. And this will return a ZIO task with unit. And I will need to import ZIO.task. Now, you can think of a task as a potentially asynchronous computation returning a particular kind of value. You can think of it as a future. And behind the scenes, a task is an alias for ZIO with the environment type any. This can fail with a throwable, and this can return, in our particular case, unit. All right, so this is our desired value. Now, the implementation of this task may or may not be asynchronous, and we want to give the maximum capability here. Now, inside of this object, I'm also going to provide a dummy implementation of the service that would send an email to this user. And for the sake of this video, for brevity, I'm going to use the console. So I'm going to define, let's call this a service implementation. Is new service, whose notify method would simply return a task, much like a future constructor, in which you will do print line sending the message. I'm going to insert message inside to, let's say, user.email. Okay, so I'm going to prefix that with user emailer so that we know from the console which message is from which service, and this is a dummy service implementation. Now, the interesting thing is that in order to make the service available to other parts of the application, we can treat the creation of the service as an effect, and we can wrap it inside an effectful creation of the service. What do I mean by that? I'm actually going to define a val, let's call this live. This is the usual pattern that ZIO usually uses, and the live variable I'm going to annotate it later, and I'm going to wrap this service constructor here inside a kind of like a ZIO succeed, but I'm going to use ZLayer.succeed, and I'm going to describe what that does in a moment. So I'm going to import ZIO.ZLayer. So ZLayer.succeed, I cannot really spell succeed. So ZLayer.succeed will create a particular data structure which is very similar to a ZIO data structure, but the ZLayer has a particular kind of type which makes it easy to be plugged into other ZLayers later in the application. I'm going to explain why and how later in this video. And the type of that is a ZLayer, which has an input type much like a ZIO instance, in our case any. The error type is nothing because this constructor cannot really fail because we've used the succeed method. And the output type is a user emailer dot service. So this is the type of the useful value that we need. This would be what ZIO would use, but this is wrapped inside a higher kind of type called has. And has is a very interesting trick that ZIO uses so that ZLayers can be composed with one another. Right now, don't care about it, and just import ZIO.has. So a ZLayer is different from ZIO in this sense, that the output type is not the value that we care about, but a has with that particular type. So not much of a difference, all right? So this is a ZLayer which contains a real implementation of this service. Now, still inside the same user emailer object, it's quite common to expose a higher level API. For example, let's call this notify with user as a user and a message string. And this is a ZIO Effect, which takes as input a has user emailer dot service. This can fail with a throwable, and this returns unit, which is the same kind of useful value that this notify method actually returns. And we can use ZIO dot accessM. AccessM will be able to fetch the instance that is provided here as the input type. So it will fetch the instance of the environment. In our case, we will access the inner service, and I'm going to say has service. And this has service is a wrapper over the service instance. So I'm going to say has service.get. And then I'm going to call the notify method. So I'm going to say notify with user and message. So assuming somebody could construct a has user email service, so if somebody could provide us with a has user emailer service, then we would be able to access that user email service by saying that thing.get, and then once we've accessed that service, we can call the notify method. Here's how we can use that in an actual main method. So I'm going to scroll up and I'm going to bring my run method, I'm going to bring it down. So the run method, which is our main method, would sound something like this. I'm going to say user emailer dot notify, and I'm going to pass an instance of that particular user type. So I'm going to define a val, let's call this Daniel, as user with Daniel and my email, daniel@rockthejvm.com. And I'm going to define another message, let's say as a string, as welcome to Rock the JVM. Right, so I'm going to reuse these variables later in my application. Now, I'm going to say user email.notify. So I'm going to say with Daniel and message. Now, this is a ZIO instance which needs an input type. And so we will provide that input type by saying provide layer. And that layer needs a ZLayer, which we've already constructed via this live instance. So I'm going to say user emailer.live. And after that, this is a ZIO instance, which we can trigger by running the method exit code. So on line 50 here, we're specifying what kind of effect we want triggered. So the kind of effect. And then here we provide the input for that effect. If that sounds familiar, I feel you here, because this is very similar to dependency injection, because here at the very end, you're plugging in a real live service that you can actually use for the effect that you want triggered. And you can actually run that effect by calling the exit code method. So I hope you get the pattern. This is the kind of service definition pattern that ZLayering actually employs, and some of the standard ZIO services, including the console, are actually structured in this way. So this is the service definition. And here we have a service implementation, and here underneath we have a front-facing API. And usually if you want to plug this layer into other layers, we also use a type definition here. So I'm going to say type user emailer env, or some other naming notation. I use the env suffix, is has user emailer dot service. All right, so instead of has user email service used directly, I'm going to say user emailer env, and I'm going to do that beneath as well. So this is the pattern for defining a service. Now, just to practice this kind of structure, I'm also going to define another ZLayer in the exact same style, which can be a user email database. So I'm going to follow the exact same pattern. I'm going to define an object, let's call this user database, and I'm going to define a trait called service. And it's quite a good practice to follow the exact same structure and the naming conventions in your various services so that other people in your organization or team can actually find or follow your code. And this trait service, let's say, has a single method called insert, which takes a user as an argument and returns a task unit. So this was the service definition. Now we want a service implementation by defining a live instance. And I'm going to have a ZLayer.succeed in the exact same way. And I'm going to define a new service whose insert method will simply construct a task, much like a future constructor here. And I'm going to print line a dummy SQL statement. So for example, I'm going to say database. I'm going to insert into the table public.user values, and I'm going to insert, for example, user.email. All right. Okay, let me put the appropriate quote because I want to follow the appropriate SQL syntax. So you get the idea. So I'm going to construct a ZLayer succeed, and inside the ZLayer succeed, I have a real implementation of this service. Now, as for the front-facing API, I'm going to define a method called insert, which takes a user as a user, and this will be a ZIO of, and here I need the has userdb.service. So I'm going to define it as a type member. So I'm going to have type userdb env for environment, and I'm going to say has userdb.service. Now, the insert method will be a ZIO Effect, whose input will be a userdb environment. This can fail with a throwable, and this can return the value unit because this is the same as the task. And I'm going to say ZIO.access m, the exact same pattern here. And assuming I have an instance of userdb environment, I'm going to say underscore get, which returns me an instance of this service. And then I'm going to call the insert method on that user. So this userdb database here follows the exact same pattern. And I've typed it myself so that you guys can have some real practice. It helps even if it's repetitive because it'll get these patterns in your muscle memory. Now, these two ZLayers that we've defined, the userdb live and the user emailer live, are so far independent, but we can compose them. And because the ZLayer type is analogous to a ZIO instance, which is also analogous to a function, it makes sense to be able to compose these ZLayer instances like functions. And one way of composing ZLayers is the so-called horizontal composition. So if we have two ZLayers, we can obtain a bigger ZLayer whose input type is the combination of both of those ZLayers input types, and the output types are the combination of both. So if I have a ZLayer with the type input 1, error 1, and output 1, and the horizontal composition operator is this ++ method, and if I combine that with a ZLayer with input 2, error 2, and out 2, this will obtain a ZLayer of in1 with in2. So this is the composite type, a type which derives from both of these types together. The error type is a super type of both. So I'm going to say E1 with E2, so to speak, but the compiler is actually able to infer the super type of E1 and E2. And the output type is specifically out1 with out2. Now, obviously, I cannot spell properly because I said ZLayer here. I am practicing Eric Clapton's Layla on the guitar, so this might have been reflected in my spelling, but I digress. So if you can think of a ZLayer as a service with a dependency and an output, then combining two ZLayers horizontally will construct a new ZLayer with combined dependencies and combined outputs. So for example, in our use case, we can combine the user emailer and the user DB because they don't share any dependencies and construct a new composite service that can provide both the insert and the notify so-called services. So I can construct a value, let's call this user backend layer, as being userdb.live ++ user emailer.live. And this would be a new ZLayer with the type any, because neither of these layers have any necessary dependencies, and so the input type is any. The error type is nothing, because neither of these services can fail, because we've constructed them with succeed specifically. And the output type is very interesting, because we have user db env with user emailer env. Now, in order to access these type aliases, I'm going to import user db underscore and import user emailer underscore. Now, what's very interesting is that this user backend layer, which is a ZLayer, has real instances of both a user DB service and a user emailer service. User DB env has user DB service and has user emailer service. And so I can use this user backend layer as a substitute for this particular call that I'm running in my main method. So I'm saying user emailer.notify, and I need to provide a layer which has a real instance of my user emailer service. And I can either use user emailer live or this composite layer. I can say user backend layer. And this application will work just as fine, and it will type check just as well. So if I run this application, this will print sending welcome Rock the JVM to daniel@rockthejvm.com. All right. And so you can pass this value around in your application and still make sure that you have all your services already implemented and specified by its type. So this was horizontal composition. Now there's also a notion of a vertical composition. Because another way of composing ZLayer is by the so-called vertical composition, which is more akin to regular function composition. So you can feed the output type of one ZLayer to the input type of another ZLayer, and the result becomes a new ZLayer with the input type from the first and the output type of the second. So for our use case, another ZLayer might be more appropriate. So let's assume that for our emailer newsletter service, when a user signs up to our newsletter, we want to store their email in the database and send them the welcome email, much like we did here in our user backend. And so we need another ZLayer which can combine these two. And so we want to be able to invoke the two services from a third service, which will have a single front-facing so-called subscribe API. So I'm going to define a service following the same pattern as before. So I'm going to define an object. Let's call this user subscription. And I'm going to define a class service. Notice I'm not using a trait anymore. I'm defining a class because I'm going to build this class with constructor arguments. So I'm going to say notifier as an email user emailer.service and the user database as user db.service. Now, I'm going to offer a single method. Let's call this subscribe with a user. And this will be a task which returns that same user. So this will be not a task unit, but a task user. I want to return this user to my calling, to my caller. All right. Now, I can combine the notifier services API with the userdb API through two ZIO effects. And so I can combine them with a for comprehension. So I'm going to say for. And for a unit which is obtained by notifier.notify with user and welcome, let's say user.name, let's say welcome to Rock the JVM. And let's say we have some nice ZIO content for you, right? And I can also combine the effect of the notify with the effect obtained from the userdb.insert with that particular user. So I want to insert my user in the database. I want to notify them, and I'm going to yield the same user. Right? So I want to return the same user to the caller. So the difference here is that the service type doesn't need an abstract method since it only uses the other two services. And concrete instances of user emailer and user DB will in turn influence the instances of this new user subscription service via, you guessed it, dependency injection. So I'm going to define a val called live, which is another ZLayer. I'm going to type it later, and I'm going to say ZLayer. And I'm going to use from services. And from services has very, very many overloads because there are many combinations of types that you can have. So I'm going to use two type arguments, and I'm going to return a third. So I'm going to say, and here in the type arguments, I'm going to say user emailer service, user db.service. And the third type argument is user subscription.service. And now with these three type arguments, I need a 2arg lambda that takes a user emailer service and a user DB service and returns a user subscription service. And so I'm going to say user emailer and user DB arrow new service with user emailer and user DB. Now, this might sound a little complicated, but it's not that complicated really, because the only reason why this ZLayer exists is so that we can plug some ZLayer that outputs this type with this live instance and obtain a new ZLayer which only produces this user subscription environment. And whenever you call the subscribe method on this user subscription, this actually calls the service that was instantiated here, which was the new service with the emailer and user DB. And once we pass these two arguments, then we are able to call their API methods. And once we call the subscribe method on this service, both the input services, the user emailer and the user DB, will already have been supplied, and so we would be able to call their internal effects and combine them together. Let's see how this is done in practice. So now we have this user backend layer, which is obtained by the horizontal composition of user DB and user emailer. Now, conveniently, this ZLayer outputs the exact type that this user subscription service now needs. So I can very conveniently define a new, let's call this user subscription layer, as a ZLayer of any, nothing, and the output type of this third service. So I'm going to use this one, and I'm going to import user subscription underscore so that I can already have access to the type alias. And I can use the user backend layer and plug its output to the input of user subscription.live. And this output operator does exactly that. This is very similar to a function composition in which the output of the first argument is plugged into the input of the second argument. And so the final program to subscribe your first fan of your email newsletter would be to say user subscription.subscribe, which we haven't defined yet. So I'm going to define a front-facing API here. And I'm going to define, let's call this def subscribe with user. And this will be a ZIO Effect, which takes a user subscription environment as input. It can fail with a throwable because that's how a task can also fail. And the return value of that task is user, which is also the return value of our ZIO Effect. And I can use the same pattern. So ZIO accessM, and I can say underscore get, which is my user subscription service. And then I can call subscribe with that particular user. All right, now let's see how we can plug that to our main program and subscribe the first fan of Rock the JVM to our fictitious email newsletter. Now, I'm going to copy the run signature here, and I'm going to rename this method to, let's say, notify Daniel. All right, so that we can keep this for posterity. This is not a def, this is not an override, but this run method is. And I'm going to use this user subscription layer by calling the front-facing API of my subscribe method. So I'm going to say user subscription dot subscribe, and I'm going to use Daniel because I already have an instance of user. And then I need to provide a layer. So I'm going to provide layer, and I'm going to use the user subscription layer. And then I can say .exit code because I want to trigger that particular effect. So let's see what 100 lines of ZIO code have actually bought us. So now we should be able to automatically add Daniel to the database and also send Daniel a message. So notice that both of our services are working correctly. They are working independently, and it's very easy to plug them together with these horizontal or vertical combinators. There are many other combination functions in ZIO, and you can play with these if you have the time. All right, so I hope this video was useful and fun. If you liked it, go ahead and click the like button for me and subscribe to the channel for more videos like these coming your way. And check out my Twitter and LinkedIn as I post fresh updates on upcoming material. Now, I'm dying for feedback, so please leave a comment. I read every single one. And check out the Rock the JVM website and the blog, where I have tons of material on Scala and functional programming and CATS and Apache Spark and Akka and ZIO and so on and so on and so on. Until next time, Daniel signing off.